Hi, welcome back to section 9.1. We just finished talking about independent and dependent variables. Now we're going to dive into some more vocabulary about relations. So what is a relation? A relation is just a set of ordered pairs. It may be a continuous function or a continuous relationship, but you could write everything in there as a set of ordered pairs in that relation. A function is a relation for which each value of the first component of the ordered pairs, there's exactly one value of the second component. So basically, for every x, there's exactly one y. That's what makes it a function. Every x value goes to exactly one y value. One y value can have more than one x value, and that is perfectly fine for it to be a function, but every x just goes to one output or one y value. In a relationship, the set of all values of the independent variable, that's all of the x's, is called the domain. So the domain is which x values are getting used in this relation. Sometimes it's a list, if you just have a finite number of points. Sometimes we'll write those in interval notation if it's a continuous relation. The set of all values of the dependent variable, those are your y's, is the range. So the range is all of the y values that get used in that relation. And again, we might write those in set notation. We might just list them out. Or we might write them in interval notation if it's continuous. Okay, so just reminding you guys, domain is all of the x values, and range is which y values we use. Okay. So next example, I've got some relations that are just sets of points. They're listed in set notation. We're going to see, are they a function? And then we're going to give the domain and range. Okay? So the first one in example 2 is function f. So we have function f, which is the points 0, 3, -1, 2, and the point -1, 3. Those 3 points make this relation. So is it a function? All right, so for every x value, it should only go to one y value. I notice that -1 x value, we have it twice, and it goes to 2 different y values. That -1 is the x value, it goes to 2, and it goes to 3. It goes to 2 different y values. So this is not a function. Okay, but it is a relation. It still is a set of ordered pairs. So we can do the domain, we can do the range. Okay, so the domain is just the set of all of the x values that get used. So the x values that are used are 0 and -1. I'll just write that in numerical order. So -1 and 0. The range are the y values that get used. So the y values, we have 3 and 2. We have 3 twice, but that's fine. But 3 and 2 are the y values that get used. And again, I'll write that in order, so 2 and 3. Okay, so there's the domain and range for that first one. The next relation that I give you, we call it relation G. And its set has the points 5, 4, 6, 4, and 7, 4. Okay? So, first question, is it a function? So every x value goes to exactly one y value. So 5 goes to 4, 6 goes to 4, 7 goes to 4. We don't even have the same x value twice for it to go to 2 different places. So this one is a function. I know that we use the same y value over and over and over again. That is fine. Y's can go to multiple x's. It's just x's go to only one y. So for our domain, that'll be the set of all my x values that get used. So my x's are 5, 6, and 7. The range is the y values that are used, and the only y value we have is 4, over and over and over again, but the range is just the number 4. All right, what if I have a graph like this one? Give the domain and range of each relation. We're going to determine if it's a function, and we're going to use interval notation as needed. Okay. So this one you'll notice, we could write all of the points. It would take us literally forever because there's an infinite number of points there because it's continuous, but it is lots and lots of points together. So it is a relation. Let's see, the domain and range. I guess it asked for that first, so we'll start there. The domain are the x values that get used. So what I'm looking at when I have a graph is basically how far left do I go and how far right do I go. In that graph, we have an oval shape, and on the left side, it goes to -2. That's where it starts. That's how far left it goes. And how far right does it go? It goes to +2. It doesn't skip anything in the middle. It's all of the x values between -2 and 2 are getting used. It includes both. It looks like it has kind of an endpoint on each. So that means that I'll use brackets in my interval notation. So that just tells me that all the x values between -2 and 2 get used. It includes the -2 and the 2 in the domain. All right, how about range? So domain, I was looking left to right. In the range, I'm looking to see how far down does it go and how far up does it go. So how far down does this ellipse go? Well, it looks like it starts down at -1. How far up does it go? It goes up to +1, and it doesn't skip anything in the middle. So all of the y values between -1 and 1 get used. It includes those. It's part of the ellipse, so we're going to use brackets in our interval notation. Okay? In case you're wondering, like, how do you know if it doesn't get used? Usually if it doesn't get used, you're either going to see some sort of like an asymptote where it approaches a line but never quite meets it, or you're going to see some sort of a hole where there's like a little tiny circle on your graph where it'll say, we don't include this one value. So that's generally what it looks like if it's not included. Okay? Let's see, is it a function? So for it to be a function, every x goes to only one y value. Visually, what I can do is do what's called the vertical line test. So I'm just going to do a quick sketch so you guys can see down here. We have a little ellipse, right? So with my vertical line test, if it goes through more than one point like that, it fails the vertical line test and it's not a function. And so we could do that a lot of different places over here to see that there are lots of x values where it goes through two different y values. Kind of goes through one on that top half of the ellipse and it goes through another one on the bottom half of the ellipse. Just for example, like at x is 0, it goes to +1 and -1. So two different y values for the same x, and it does that over and over and over again throughout the whole ellipse. So this is not a function. All right, let's do another one. Example 4. I have a nice little parabola, and you can even see the equation of it if you'd like. Y equals x squared minus 3. We're going to give our domain, we're going to give our range, and we're going to determine if it's a function or not. All right, so domain, again, I'm looking left to right. So this one, you'll notice there's arrows. I know it's kind of convenient to be like, oh, does it just go from -3 to 3? No, because there's arrows, which tells me it's going to keep going up and to the left. It's going to keep going up and to the right on the other side. So because it's going to keep going left, you know, I know that it's going to go up faster than it goes left, but it is going to keep going to the left forever. That domain starts out as -infinity because it's going to keep going to the left forever. On the right side, I know it's going up very quickly, but it is going to also keep going to the right slowly. But the important thing is that it's going to keep going to the right. It's not just going to keep going up straight. It's going to keep going right as well. So we're actually going from -infinity to +infinity for our domain. We will have parentheses in our interval notation because we don't include infinities ever. All right, let's look at the range. So again, range, we're looking at how far down does it go and then how far up does it go. So this one, how far down does my graph go? It starts out at -3, and it includes -3. That's kind of its vertex point down there, comma. How far up does it go? And I think these arrows make it very clear that it's just going to keep going up forever in that positive direction, so we're going to use a +infinity on that side for the range. Is it a function? Well, if I go through that vertical line test again, here's my little parabola, every single point that I try to do a vertical line, it will only go through once. So this one is a function. So every x value only goes to one y value on this. And if you want to look at the function up there, the y equals x squared minus 3, no matter what x you put in, if you square something, it's just going to give you one value. You subtract 3, it only gives you one value. So you're only going to get one y value for every x that you input. Alright, now it's your all's turn. You get to try one and show me how much you've learned.